So let's talk about the fundamental theorem of calculus as a result of this fundamental theorem, which states that the definite integral from a to b of f of x dx is equal to the antiderivative at b minus the antiderivative of f at a. So we have our expression right here. We're going to take the antiderivative of 4 minus x squared and use that to evaluate the definite integral from 2 to 4 of 4 minus x squared dx. So when we do that, of course, that we're going to take our antiderivative, and we recognize that to be 4x minus the antiderivative of x squared, which is 1/3 x cubed. And we're going to evaluate that at 2 to 4. Our notation right here, we take this bar after the expression to show that we're going to evaluate the expression before it at the values 2 and 4 and subtract. So in this case, that looks like 4 times 4 minus 1/3 of 4 cubed. And we're going to take away from that the quantity 4 times 2. Minus 1/3 of 2 cubed. All right, so we do a little bit of simplification right here. This is going to be 16 minus 64 thirds. And we're going to take away from that 8 minus 8 thirds. If we work this through, this would be negative 16 thirds. And 8 minus 8 thirds is also 16 thirds. So we end up with this negative value of negative 32 thirds. Right? So we can end up with a negative value from that. Very interesting. All right, well, let's talk about this one. We've got the definite integral of 1 to 5 of the expression absolute value x minus 2. Well, we can use some of our properties of the definite integral to help us with this one. And the reason why we might need that is to remember that, well, if it's an absolute values can be rewritten without the brackets if we recognize that the behavior of the function is going to change at certain points. And we'll recognize that the absolute value of x minus 2 is the kind of function that will look like x minus 2, but only when x is greater than or equal to 2. And it will look like the negative of x minus 2, so we could write negative x plus 2 whenever x is to the left of 2. So the implication for our expression is that this is really going to become a definite integral that would be evaluated as a definite integral from 1 to 2 of the quantity negative x plus 2 dx plus our definite integral from 2 to 5 of the quantity x minus 2 dx. And now we would evaluate our antiderivative as appropriate. And we would see it as the antiderivative of negative x plus 2, which is negative 1/2 x squared plus 2x on the interval from 1 to 2, plus the antiderivative of 1/2 x squared minus 2x on the interval from 2 to 5. All right, so let's work out some of the numbers right here. In the first case, it'll be negative 1/2 of 2 squared plus 2 times 2 minus negative 1/2 of 1 squared plus 2 times 1. Added 2, and the quantity that we get here in the next term is going to be 1/2 of 5 squared minus 2 times 5 taking away the quantity 1/2 of 2 squared minus 2 times 2. Just a little bit of work right here shows that this is really going to be the quantity negative 2 plus 4 minus the quantity 3/2. 2 minus 1/2 is 3/2. Added 2, and in this case our quantity is 1/2 of 5, 5 squared. Well, it's going to be 25/2 minus 10, and we're going to take away from that. Well, in this case, that's going to be 2 minus 4. Just a little bit more work right here shows that we have 2 minus 3/2. Added to 5/2 plus 2, which stated in another way is 1/2 plus 9/2, which becomes 10/2, and that is going to be equal to 5. So our total area right here, our total definite integral is going to be 5 on the interval from 1 to 5. That's what we wanted.